thank you very much for the organizers for inviting me to this very, very attractive for every toxinologist meeting. And I'm really very sorry that I'm not there with all of you. And of course, to talk after Juan, it's a big challenge. So with his fantastic talks, that's why we are very, very out of time. But I would like to try to be as quick as possible. Now, for my talk, we are very, very out from the logic of from ground to up, because we are much more interested what's going on that top of the effect which venom composition together through synergy could have on the organism, because even with all that ton of different investigation that already we have with proteomics and other approaches, it is still a great enigma what's going on the organism level when the venom will be injected in the organism. So historically, snake venom research has involved the reductionist approach, which is, I think, pity, because of course this has been a necessity, because isolation and characterization of individual toxins has been the only feasible option to clarify the mechanism underlying the complex pathological state induced by snake venoms. But there has been a tendency to ignore the fact that snake venoms are integrated multi-component systems. While conceived and refined with an ultimate purpose of assault or defense, the snake venom biology is have developed during the evolution unprecedented potency and selectivity for rapid interference with specific function processes with disruptive and devastative effects on a wide range of fundamental biological processes. And synergy is very important, because to have such a trace amount of venom, it is very important to have the effects very, very quickly and fastly. For my area of professional interest, please meet our venomous beauty, which is Macrovipera libizina obtusa. And we've also done all which is necessary for proteomics with the help of Professor Calvet in many years ago. And we do know that the venom composition of this snake, which is quite serious and could be very, very lethal, composed from almost more or less 10 different families of potent components. Some of them are quite abundant, like snake venom metal proteases, P1 and P3 mainly, and some of them are also predominant, like PLA2.
No, Naira, no,
Yes.
this is Glenn. Your slides aren't changing. Are you on slide 3 now?
No, I'm not trying to change.
Oh, okay, that's all right. We weren't sure. That's okay. Go ahead.
Okay. So once again, do you have now it?
Yes.
Venom composition and synergy.
Yes, we've got it.
Yes, yes. So we have another very predominant toxin family, which is PLA2s, as in many other vipers, and especially the vipers of the so-called old world. We have a big amount of serine proteases and also a number of pool of disintegrins, including dimeric disintegrins and short disintegrins. And what was our interesting approach to all these cases? We have a ton of different investigations concerning the different fractions of these toxins on the metabolomics and condition of membrane and condition of cells during envenomation. But for all these cases, the whole picture is not that obvious as we would like to understand what happened on the organism. Excuse me, Abdullah.
Could the online participants please mute your microphones? Abdullah, mute your microphone.
Okay, so for this case, we've done such kind of experimental design when we are trying the whole venom composition, but trying to inhibit some different predominant families of the actors like PLA2, snake venom metal proteases, and serine proteases. Uh, so we do have such kind of venom with switched out PLA2s and metal proteases. The experiments with serine proteases are very, very preliminary, so it is not demonstrated here. First of all, of course, we've tried to see how this kind of approach can affect the comparative lethality and toxicity and LD50 of the MLO intact venom. And as you can see at the very end, they all come to the lethal potency, but with the very different ways. And of course, nothing could be compared with the intact MLO venom. For different parts and stages of our investigation, we've tried to see the synergy of different isoforms of PLA2s, even from different species of snake together on the model membranes, which is the main scientific interest for us to idealizing somehow the condition of cell and make models which could be quite accurately mimicry the whole cell, but with some idealized conditions. Like erythrocyte ghosts, we find them very good model for the cells with membranes and membrane proteins apparatus within it, and giant unilamellar vesicles from the whole fraction of phospholipid served like the negative control of such kind of situation when we have a membrane but without proteins. So in past years, we've tried to see the synergy between so-called classical D49 PLA2 from macroviparal lipids in aptusa with different isoforms from with substituted residues in a very important 49th position, like K49, which is substituted by lysine residue in Botrop Asper, and also we've tried the serine 49, Vipera ursini reynardii toxins, and you can see if we have the very potent action on the giant unilamellar vesicles by image with the fluorescence on, in a real-time mode, the whole venom action is quite drastic because it is shrinking very fastly. It could be even immediately if the concentration is quite high. But in case of K49 and S49, we can't see any changes of the shape of the giant unilamellar vesicles, while in case of D49, it's also not such a potent and drastic changes, but we have some certain deformation of the membrane, which is absolutely witnesses the changes of membrane lipids penetration and condition. Now, when we try to use together S49 and D49, in, of course, in presence of calcium ions, which is very important, we see again not such a active reaction as during the venom itself, but again, the situation is much more potent than in case of different venoms. To go further, we've tried two interesting membrane zones, fluorescence proteins, which are able to show us the condition of biological membrane, lipid bilayer, through their interaction with the lipid bilayer hydrophobic core. Both of these zones, Laurdan and Prodan, as we call them, are the derivatives of the naphthalene. And the difference is only this long acyl residue in case of Laurdan, which lets it go deep inside to the core of lipid bilayer in the hydrophobic part, while Prodan position are much more on the surface, and with its interaction with the hydrolyzed surface of the membrane and the lipid so-called heads. It's give us the information how the water able to penetrate inside the membrane, which is certainly talk about the lipid packing and membrane fluidity. And so with calculating so-called generalized polarization
Naira.
function, yes?
Which slide should we be on? We're still on slide 2.
Oh, no. Sorry, now it's nothing changed?
Nothing's changed. No, we're still on slide 2.
And what about this?
No, still on slide 2.
Oh my God, sorry. I'll try to share once again.
Oh, now it's moving. Yeah, we're on slide 3 now.
Is it?
That's slide 3. Yep.
And this?
Yep, slide 4. Now it's working.
Okay, so that's what I'm talking about.
Perfect.
This is the Prodan and Laudan derivatives, which is naphthalene fluorescent zones for the membrane bilayer, and they are able to give us the information about the lipid packaging and the water penetration into the hydrophobic core of the lipid bilayer. Again, as in case of the previous just biovisualization series of experiment, it is very quite interestingly, we see that in case of K49, it's not such a noticeable effect as in case of other toxins. But here we didn't try that together, but we've tried some other approaches concerning the lipid bilayer condition and GP values with 2 PLA isoforms isolated both from the same macrovipera lipidina obtusa venom. As I've already mentioned, in the venom of macrovipera lipidina obtusa, there are few isoforms of PLA2. It is mentioned that maybe there are 6 products of 6 different genes, and these isoforms, they are all of them are the so-called classical D49 isoforms with the aspartate in the position of 49, but still you can see that the effect of these PLA2 isoforms on the membrane generalized polymerization values are quite different concerning from the fraction 1 or 2. And what is most interesting, of course, that together these 2 fractions are able to show the most more noticeable and remarkable changes in the condition of lipid packaging and water penetration into the bilayer than each of them. The same is true also for Prodan. So it is not only on the concerning the hydrophobic core of the lipid bilayer, but also concerning the alteration and damage of the surface of lipid membrane. Interestingly, when we try to use erythrocyte ghosts instead of the giant unilamellar vesicles, we are not able to see such differences between fractions and also no any synergy concerning the joint action of fraction 1 and 2. And with this result, we think that erythrocyte ghost membrane proteins, there are so many, and there is no real two free opportunities to reach the bilayer for these PLA2s. And also, of course, it is very important the thing of lipid membrane curvature, which is crucial for the work of PLA2, especially if we talk about the enzymatic isoform 1, which is this. So after these investigations, which was published in different years, and this one was in 2019, we've tried to understand that how change the condition of membranes are very much very much dependent from the oxidative stress and the action of PLA2. It is quite known, and there are a ton of different publications concerning the oxidative stress, which could be noticed during the PLA2 reaction with membrane of different type of cells. In our investigation, we used the Vero cells, which are normal epithelial cells, and so-called Sears technology, which is a very interesting approach, which give us the information about the differences between oxygen consumption rate and extracellular acidification rate. In case of this technique, the assessment of the mitochondrial respiratory, which is based on the oxygen consumption rate, or so-called OXPHOS, or oxidative phosphorylation, it's compared with the rate of glycolytic extracellular acidification rate, and the capacity by respective stress test or Seahorse technology enabled determination of the bioenergetic phenotype of venom processed cells. For this case, we find that the most important challenge, which was in this case, to find a very good active concentration for venom, and we've done it with empirical preliminary experiments, and we've noticed that 1 microgram per milliliter for 20,000 for the cell culture of 20,000 Vero cells used in this study is the concentration which is capable to induce minor metabolic changes, while the concentration of the experimental compounds injected at 110
O
microgram
Silvio tinha que
milliliter.
trazer, mãe. Ah, eu ia falar para a senhora, esqueci.
Denise,
Fazer
Denise,
pastel. Dá tempo?
Denise, can you mute, please?
É, 11h30, mas eu vou pedir para o Silvio trazer, então.
Okay.
Denise, you have your
Eu
microphone.
esqueci.
I hate the online meetings. Okay, so these are the concentration which are relevant to the, of course, this is such kind of speculation, but we've decided that they are relevant to the lethal and sublethal physiological doses for the venom based on the previous experimental findings. Again, as I've already said, oxygen consumption rate let us measure the rate of mitochondrial respiration of the cells, while extracellular acidification rate is the proton concentration in the assay medium. So it gives us the opportunity to rate of glycolysis of the cells. As we do know, glucose and glutamine as the main carbon sources of mammalian cells are essential for ATP generation, and biosynthetic reactions and glucose and glutamine have so-called overlapping metabolic functions. But they give quite precise information whether the alteration and changes touch the mitochondrial respiration, of this is more on the surface of the cell membrane. So irrespective of the cellular metabolic background, which we've noticed, when pre-incubation induced a shift of the bioenergetic state of epithelial Vero cells to a higher oxidative and glycolytic levels. But what is the interesting, blocking of the major venom component, PLA2, totally inhibits the ability of the venom cocktail to induce a significant increase in metabolic activity. While the similar blocking of the other basic set of components of the venom, which are the P1 and P3 zinc metalloproteinases, appear to be rather negligible for venom-induced stress. We've done also the classical MTT test, and it is interesting that for this case, it was not a big changes when we tried to switch off whether both PLA2 and metalloproteinases, and in all cases, and even at the lowest concentration, the viability of cells decreased until 80% compared to the vital cells, to the control. We also tried to assess the ROS generation in a real-time mode due to the ROS production during the chemiluminescent analysis with these three different set of probes. And again, surprisingly, in case of the phospholipase inhibited condition, it is more oxidative stress when compared with the metalloproteinases inhibited case. And the situation is absolutely correlated with the data of lipid peroxidation, which we've done with the TBA test. Again, a classical test to assess the lipid peroxidation by malonic dialdehyde concentration accumulation within the membrane. In this set of experiments, we would like to conclude that venom injection induces a metabolic shift of cells to a higher energy level. But if the MLO venom causes the activation of both glycolysis and mitochondrial respiration, the switching off of the phospholipase and metalloproteinases activities of the same venom exclusively push the oxidative phosphorylation, but not the glycolysis. At the same time, the venom-associated increase in glycolysis could also be a compensatory mechanism for the generation of reactive oxygen species through the higher rate of mitochondrial respiration. The direct measurement of the ROS generation in a real-time mode shows that zinc-dependent metalloproteinase activity as a main culprit of the oxidative stress induction, while surprisingly, the inhibition of the market activity leads to the antioxidant effect of the venom on the free radical processes. This is an unusual situation when we could look at the PLA2 as an antioxidant, but highly likely that for this design of experimental approach, this antioxidant phenomenon of PLA2 is not the only one responsible, especially if we'll take into account that these integrins are cysteine-rich peptides known as strong antioxidants. And we have quite abundant amount of different disintegrins with disulfide bonds, many of disulfide bonds in this venom composition. And disulfide bonds is quite well known the traps of reactive oxygen species. Now we are concluding this experimental approaches. I've already said with the third most abundant enzyme of the venom of macroviperol libizina obtusa, which is serine proteases. And I think with comparative analysis of all these different parts of switching off components will give us the specific information concerning the synergistic action of these components. Well, actually, it's already a few years. We have a number of publications devoted to the synergistic action of various PLA2 isoforms, both enzymatically active or non-active. There are works about PLA2s and together with snake venom metalloproteases, together with three-finger toxins, and in some cases also very few publications concerning the synergy with disintegrins. But such kind of approach seems to us more, more interesting and more original to understand the synergistic action of venom within the organism. Of course, it is yet on the level of cells. And with my thank you for your attention, I would like to invite all of you soon in October to another one big toxinological meeting in Abu Dhabi, and we are really expected that the meeting will be very interesting and exciting, and please join us there. Thank you very much.
Thank you, Naira, and thank you for being patient with all those technical difficulties that we had. I know there's an online question from Maria Okonomopoulou, so could you read out the question?
Should I read it?
Yes, could you read the question, please? Thanks,
yeah,
Naira.
Sure. Hi, Naira. Hi, Marina. Which specific parameters of OCR, basal respiration, ATP, max mitochondrial respiration, etc., and Descartes glycolysis, glycolytic capacity, etc., you found mostly to be affected? Well, it seems to us that glycolysis is more affected, and as a compensation, mitochondrial respiration increasing quite noticeable, especially in case of the inhibition of PLA activity. This is what we can conclude from this set of experiments. But we are, of course, continuing.
Thanks, Naira. Are there any questions from the audience here? No. If not, I think we should end there because we're way behind time. Thank you, Naira, for being so patient with all our technical difficulties.
Oh, thank you also for your patience.